This is the SAP reference architecture that will be deployed using the Terraform. We're using a single AD deployment. We're going to deploy everything on Availability Domain 1. As you can see, we have a Bastion host on the public subnet, along with the SAP Web Dispatcher and the load balancer that will be put in front of the SAP Web Dispatcher as well. On the private subnets, we have our SAP application server, our SAP Oracle database, our SAP router, and our FSS services to support as a NFS file system share among the services. Let's just switch screens and I'll show you how we can deploy the SAP infrastructure in OCI. So in order to do that, we have a GitHub repo on the OCI Quick Start organization. There's a OCI SAP repo. You can see here there's some details on how to install Terraform on your own machine. So in order to start it, we're going to go here and we're going to clone that repo. I'm just going to copy that link. And I'm going to go to my terminal here and hit git clone. And I will clone the repo. So now we can go inside of OCI SAP, the directory that was created. And then if we check the files here, we go to the single AD directory, and we can see all the Terraform files created, right? So here is where you're going to see all the resources that will be provisioned on the OCI infrastructure. If you look at those files, you can see their names as load balancer. That's going to contain all the load balancer information. The scripts for SAP, where that's going to go and execute all the configuration inside of the machine in order to have the file system created and everything. You can see the others like compute, block, FSS, VCN as well, right? So you are free to navigate it and explore those files, and especially the variables.tf file, where you can change some of the configuration that you want to match on your infrastructure. You can change, for example, the CIDR block of your network. You can change the shapes of your virtual machines that you want to deploy, right? So if you just go back real quick here on the repo, we can also navigate it through the web, and you can see that information right here, right? So if you go and check, for example, your variables file, you can see all that information here. So you can change your CIDR block, you can change the shapes of your virtual machines, the operation system version, and so on. Okay. All right. So let's go for a quick deployment. Once we clone, we're gonna do a Terraform init. We're gonna initialize the Terraform. And now that we did that, we can just do Terraform plan. And we can see that 51 resources will be added to our infrastructure. So plan is just going to go over and show what exactly is going to happen, all the resources that will be deployed. And to actually apply that, we're going to do a Terraform apply command. And we can just say yes and confirm that we want to deploy. So now the script is running, so that's going to go over and start creating all the resources inside of OCI. If I switch over to the browser one more time and go to my Oracle Cloud account, if I check here under the menu, go to the networking side and the virtual cloud networks, I can change here to my SAP compartment. And then I can see that the VCN was created already. We have information about the subnets that's required to stand up the infrastructure, right? Stand up the compute resources. I can see the NAT gateway, service gateway, secure lists as well, right? So this script's gonna take a few minutes to run. I'm gonna pause the video here and I'm gonna come back when it's done. All right, so we can see that I have 51 resources created on our infrastructure. So Now we can go back here and we're going to take a look at one more time and make sure that everything was created correctly. So on the network side, as I was explaining, the VCN was already created, right? All the subnets, secure lists, everything that's related to the network was created here. If I check the load balancer portion, it also created the load balancer, right? As of now, it's saying the critical condition because I didn't install the SAP application on the web dispatcher yet. But it's actually pointed out to the backend of the web dispatcher's servers. So if I go to the compute instances, we can see that all the instances were created here. The database was created, the SAP router, the Linux application, the web dispatcher, and the Bastion host, right? So we spin up, it created all the resources for you. So now you can just access those machines using SSH for Linux through the Bastion host, right? You access those private machines on the private subnet. You can also use VNC if you want to in order to install and see the graphical interface.
So security is a top priority, and by default our SAP resources on OCI use isolated private subnets, so external access to those resources are blocked. But your SAP instances can get access to the internet, like download external packets or install packets through Oracle Cloud Net Gateway, which is configured by default with the Terraform stack used to prepare your SAP infrastructure resources. So to summarize, public access, ingress, is blocked, but egress is available for your SAP resources in the cloud. How can you access your SAP resources then? If you have configured IPsec site-to-site VPN and or have a direct bandwidth connection between your on-premises data center and your SAP on OCI environment, like Oracle Cloud Fast Connect, for example, then you can simply connect your SAP to your SAP instance on Oracle Cloud using its internal IP address. But what happens if you have not set up those services? So how can you access your resources in the cloud? That's why you need a Bastion or a Jump server instance. Put in a few words, a Bastion server is just a compute instance on a network used to access and manage devices in a separate security zone. The SAP on OCI Terraform stack creates a Jump or Bastion server for you in a public and isolated subnet that allows you to connect directly into your private SAP instances. You can also use them as a public-facing resource to transfer files from your local on-premises desktop, for example, to the cloud. You can use those Jump or Bastion servers to transfer your SAP binary files. Furthermore, the Terraform stack also installs the Linux GUI and enables VNC in case you need to access the Linux desktop in the cloud. As an optional use case, you can also use your Bastion server to hold your SAP GUI client in case you need to have an easy access to your SAP data. So let me show how it works. First, this is the Oracle Cloud UI. Let's check your Bastion server information first. So these are all the resources provisioned by your Terraform stack. So here is your Bastion Linux instance. As you can see here, the public IP address is on the screen. Now, back to your workstation. Let's check the security shell configuration for your Bastion server on your local desktop. As shown here, this is the public IP for your Bastion server, and it's pointing to the private key that I'm using when I provision the instance. Along with that, I also included other machines like the SAP database, the router, the web dispatcher, and the application server. Now, if I want to connect into my Bastion server, all I need to do is use secure shell, SAP, Bastion, then there you go. I've connected into the Bastion resource in the cloud. Then I can run all the tasks that I need to run. What if I need to transfer files? For example, here in this demo folder, I have demo file. And if I want to copy this file to my SAP database in the cloud, how can I do that? I can use SCP on Mac and Linux, or I can use Wing SCP on Windows to copy this file. So for example, let's just do SCP, SAP demo file, and then all I need to do now is I just need to point to the machine where I want to upload this file into my cloud resource. So let's use SAPDB. Let's send this file to TMP folder. And now the file is being copied from my local machine to the cloud. Let's go and check that out, make sure the file is there. So let's log in into my SAP database machine, which is completely isolated. So I'm using my Bastion or jump server to get access into that machine. Now let's go into the temp folder and check if the file is there. And it's here. So the upload was successful. This is one way using the command line, but for those users who prefer to use the GUI, how can we access our servers in the cloud using the GUI interface? It's very easy as well. As I mentioned in the beginning of the presentation, by default, the Terraform stack provisions and configures VNC for you. So to use a VNC in the cloud, all we need is a VNC client. So let's use this public IP here. For this particular demo, I have here VNC viewer, and I have configured my VNC server. So let's just change here the public IP to the public IP address of the Bastion server. By default, it's using port 5901. So save it. Let's click twice. And there you go. This password here is set up by default. So if you want to enable your own password, please go in the GitHub, check the README file, and it explains where you can change the VNC password right here. It's available in the script SAP Bastion server. So I've changed my password. Let's go back to the VNC session and let's use the password that I've set. I just connected into the GUI interface of my machine. So this is a GUI access through the cloud using VNC client. This is one way to get access to your machine. Another option is using Serial Console, which is a feature of Oracle Cloud. So if you want to use Serial Console, go here in Console Connections, create one console connection for you, and there are two options with the Serial Console. One is Secured Shell, which is similar to this SSH demo we did a few minutes ago using the jump server, or VNC. If you click here on the VNC, there's this nice command line you can copy, go back to your terminal, and just run that command, like shown here. After you do that, by default, you will get access to VNC using port 5900. Now going back here to the VNC viewer client, I have that enabled here, so let's check the properties. As you can see here, it's pointing to the localhost 5900. Let's try that again. Click twice, and boom. We have connected again to the same VNC using Serial Console. So the cool thing about using Serial Console is that you do not need to have a public VNC access. So if you are going to use Serial Console, you do not need to enable VNC. So there are multiple ways to get access to your cloud resource in the cloud. So that's it.
One will be using the SAP Linux app tier, and this is IP address is private. We do not have a public IP address for this environment, and the host name is going to be the SAP LNX APP server. We're going to connect into this using the serial console that we showed earlier in the Bastion server, and here's where we would be coming in to copy and connect with VNC. Here we are on the VNC session through the serial console. We have opened up a terminal window, and we'll be starting our install from here. I'll do a DF to show you the current file systems that we have. We have the user SAP as a mount point to block storage, as well as the Oracle client as a mount point to block storage as well. We have the software, where the installation media is, the SAP mount, and the user SAP trans, which are all part of our shared file system that the Terraform script created. We utilized SCP to copy the software files into the software directory. There are our install files For this, we're going to start off by going to the Software Provisioning Manager. And here we're going to need to run the Software Provisioning Manager as root, so we'll do a sudo./sapinst. Once this finishes extracting the software and running the initial SAP install file, it will display a URL that we can access then through Firefox. If this prompts you for a user and password, it will be your root user and password for the root user as well. For the install here, we are simply just going to be showcasing the install process. We're actually not going to walk you through and explain each step here because this video is just to showcase installing SAP on OCI. We'll be picking SAP NetWeaver 7.5, Oracle, installation, application server ABAP, and we'll be doing a distributed system. As I said, the first step in this would be installing the ASCS instance, so we'll go ahead and select that. Next. We'll be doing a new install, and we'll be taking typical so we don't have to answer all the detailed questions. So this completes the installation of the ASCS instance. We'll just simply say OK to finish the process, close out of the survey, and exit out of the installer. And one final step is to validate that the system was installed and the ASCS services are running. We'll go to the terminal, we'll do a PS-EF, and we will grep on ASCS. For this install, we're using a VM dense IO. This will take advantage of NVMe storage. We could also utilize a bare metal instance or Oracle Exadata Cloud Service, which is only available in Oracle Cloud. This provides rack as well as the other advantages of utilizing Exadata for high performance. Again, this environment has no public IP address, and we'll be using the serial console as we've done in the past to proceed with the installation. On the VNC serial console, we've already gone through the same in steps to run SAP inst, and we're ready to start the database instance install. Only Unicode is supported for OCI. Again, this is where we're choosing a single instance on file systems. To utilize rack and ASM, we need to select Oracle Exadata Cloud Service as our installation shape. Okay, at this point, the installer is going to pause, and we need to go actually and run the Oracle software installer. It provides steps here where you need to log in as the Oracle user. You need to set your X display, and you need to actually run the installer from a particular directory, as well as set your DB SID to DEM. So we'll go ahead and do that right now. Already ahead of time, I've set my database SID. I've set my X display. I've actually validated and tested that, and now I'm going to software directory as it points out. At this point, we need to run two scripts as root. We now can return to the SAP installer and hit OK to continue. Okay, so now that the process has completed, go ahead and hit OK. The SAP application server install. Again, we are using a virtual machine and it has no public IP address, private IP address of 10.0.2.2 that we'll need later on when we try to access the SAP environment through the SAP GUI. Again, we'll be connecting to the environment through the VNC serial console as we've done in the past. Here we are at the SAP install. We've skipped the initial steps. We're going to now click on Primary Application Server. Take the typical settings again. We found the profile directory to identify the database and the ASCS environment. We'll need to enter in the SAP schema from when we did the database installation and select the correct database software version. Okay, the software install has now completed. We'll hit OK. Again, skip through the survey and hit exit to end the installer. One further step would be to switch over to SAP GUI and validate that the instance is up and running. Here we see our SAP logon. We have our server with the IP address of 10.0.2.2 that I pointed out in the beginning with a SID of DEM and an instance of 01. And being that this is our first log on, you'll see we have to acknowledge copyright and it's compiling the code for the first time within SAP, very common. The SAP Web Dispatcher. We will be connecting to the environment again through the serial console for the VNC, and we're installing on a VM standard image this time. We've already started up the SAP installer, the same as we've done before. In this case, we've gone down to the generic options, and we've selected Web Dispatcher Unicode. Typical installation. Okay, so the installation has completed. We're going to select OK, skip through the survey, and then click Exit to close the installer. We can see the Web Dispatcher is running, and then we're going to go into Firefox and validate that we can actually access and we are actually connected to the Web Dispatcher and showing all the processes running. The Terraform script also implements a load balancer, so we can access the Web Dispatcher from a public IP address. Now we will take a look at the load balancer configuration. Using the Web Console menu located in the top left-hand corner, select Networking and then Load Balancers. Here you can see the SAP load balancer configured by Terraform having a public IP address and current health status. Clicking on the SAP load balancer displays additional details like the assigned subnets and monitoring metrics. Navigating to the backend sets and then update health check shows it is using HTTP port 44300 and the specific URL path. As you can see, we have a public IP address utilizing the same port and the same path. And connecting to the same Web Dispatcher and able to manage Web Dispatcher from public IP address. SAP router installation. For this installation, the Terraform created a VM standard 2.1 with an IP address of 10.0.6.2 and no public-facing IP address. This instance was created without a graphical user interface, so all interaction with the environment needs to be done through an SSH terminal session. In order to accomplish this, I will create a VNC session from the Bastion server and SSH over via the terminal. I also created a load balancer configuration. This will allow connections from the internet to access the SAP router and be redirected to the SAP application server. Let's take a look on how I created the configuration for the load balancer. Utilizing the same load balancer that was created by Terraform, which currently has a critical health status. And the reason for that is because I have configured the load balancer to monitor for the SAP router, which has not yet been installed. As you can see, the load balancer is still using the same IP address of 129.146.153.230 on the public interface. There are two private subnets associated with this, which I'll refer to later on. Scrolling down, we go to the backend sets, and we can see that the Web Dispatcher is in status of OK, while the SAP router is in critical. If I look at the monitoring configuration, it is monitoring port 3299 via TCP. Clicking on the listeners, you can see that I've configured the listener to listen on port 3299 for TCP. Now let's go ahead and install the SAP router. Here you can see the VNC session with a terminal session opened that I'll begin to do the install from. The first step is to SSH over to the SAP router server. And I need to change to the SAP ADM user. Next, I will be changing into the directory user SAP router. As you can see, there are no files in the directory. I will now extract the contents of the SAP archive file that's located in the install files directory. 3 files were extracted. I also will need to copy over a configuration file that I've created already. This file is called the SAP route tab. This file is what's used to configure the SAP router to listen on particular ports. I will pull up the route tab file to show you the contents and the permissions that I've already established. The first set of permissions that I've granted are permitting access from the 10.0.1.0 subnet to the SAP application server 10.0.2.2. It is allowing traffic on ports 3600 and 3201. These are the ports that the ASCS listens on and the SAP Messenger server for the DEM environment. These 2 rules were set up for the internal use of the SAP router. I've created these other 4 rules to listen to connections that will be coming from the public interface of the load balancer. And I mentioned earlier that there were 2 private subnets that the load balancer connects to. That would be the 10.0.7.0 and 10.0.8.0 subnets. And I need to also allow the ASCS, and the message server connect to both of those. The last rule here denies all other traffic that is not permitted above. For a moment here, I will switch over to the SAP GUI and show you that I've created a connection to the SAP environment directly without using the SAP router. You can see that it's connecting to 10.0.2.2 and it found logon group, and here's that port 3600. When I initiate the connection, I am prompted for a logon, and you can see that it's actually the server it's connected to is SAP LNX APP, which is the host name for the IP 10.0.2.0. Close out that session. I will now start the SAP router. The command to start the SAP router is simply SAP router minus little r minus capital R to point to the route tab file. By default, it looks in the existing directory. I just, for this example, want to show that I am actually using that file that I showed you earlier, and an ampersand to run the process in the background. Once the SAP router has started, we can go ahead and monitor the environment with a SAP router minus L. We see that we have no connections right now except from the local host, which is the SAP router running itself. You also see the directory that it's running from and the actual config file it's using. Back to the SAP GUI, you see that I've created a logon to the GUI using the private private interface of the router, SAP router. And it is connecting to 10.0.6.2, which is the SAP router. I've been able to establish a connection, and if I issue the monitoring command, you'll see that I have 1 session through the SAP router coming from the Bastion server. I now have one created where I'm using the public interface. So I'm actually sending the traffic out of the OCI and back in on the load balancer using the IP address of 129.146.153.230. I'm also able to get a connection to the SAP application server. And if we look at the monitor of the SAP route tab, you now see that I have a session that's been initiated from the 10.0.8.2, which is the private subnet that the load balancers are connected to from the public internet. That ends the SAP router installation video.